So thanks everyone for coming to my talk. I'm going to talk about things which I'm really excited for the last several years. So that's why I like when people refer to me as Terraform AWS fanatic. One of the reasons for that is that I've been active in AWS and Terraform community for the last 3 years, and I'm one of maintainer of Terraform AWS modules. In my spare time, I organize different events and participate as actively as possible in different open source activities. So if you have any questions after the talk and don't have chance to ask here, don't hesitate to tweet or reach me anyhow. I really like to answer questions, even if you're shy. So this talk is about resources. Resources in Terraform is literally approximately 1,000 of different pieces. So you can achieve this by doing different things, like clicking in console, or even draw them, like using Cloudcraft in browser and visualize what's going to be created. But in the end of the day, resources is just the EC2 instance or S3 bucket or RDS. I'm going to use terms which are related to AWS simply because that's what I work like full-time on that. You can definitely convert this into your favorite public cloud provider or any other provider. As Mitchell mentioned during the keynote session today, as a Terraform is good not at managing just the same resources which you can manage using CloudFormation, for example, but it's also good as a glue between different providers. And as of now, there are lots of them. So that's why amount of resources is about 1,000, which is fairly a lot. So this talk is going to be about Terraform, and I just want to know who is using Terraform in production or familiar with concepts. So excellent, because I have only 1, maybe 2 slides about basics so that we don't go in what is already described in documentation. So Terraform is a tool to write, plan, and create infrastructure as code. And resources which are part of this infrastructure can be very, very different things. So you as a developer write something like a TF file where you declare what kind of resources you want to create. In this example, I create S3 bucket with random name. Then I run Terraform init command to download dependencies like plugin for the providers of specific versions. And then I run Terraform apply to see what's going to be changed. And then when I apply this and I confirm that's what I want, I see that my bucket csnail has been successfully created. So that's, in essence, everything what Terraform is about. Declare what you want, execute command, and get result. Nothing more. But the thing starts to be complicated because after you created something, you then realize that you will have to update it, right? It's not static things. So, and even more complicated things will be when you realize that Terraform is such a dynamic project, which is being released every 2 weeks to every 3 months. It depends what kind of components you look. If it's core, then it's releasing not so frequent because it doesn't have to be changed so often. But if you're looking at specific provider version, then it releases much more frequently, literally every 2 weeks. But this talk is going to be about resources and what you have to pay attention when you are declaring or describing your infrastructure. And in particular, there will be some information which hopefully you can apply immediately and stay forward compatible with upcoming versions, which will be happening quite soon. So to put everyone on the same level, I would say, let's just go through Terraform primitives, which are important for this specific talk. So there are resources, data sources, variables, and Terraform state. There are 20 other different types of primitives and concepts which are well described in Terraform documentation. I don't want to go through that. They're not so relevant for this talk. So resources support CRUD operations to create, read, update, and delete. That's all. They can also contain some lifecycle to make sure that you don't want to destroy resource by accident. And by the way, who is familiar with AWS concepts? Like if there is term like elastic IP address, does it make sense for everyone? Sounds like yes from the end. Yes. So this specific example of the code, as you can see, has lifecycle create before destroy to make sure that new instance is launched before old one is destroyed. And similar can be applied for bucket, which contains very important information which you don't want to lose. So then you have to specify prevent destroy equal true. Data sources is similar to resources, but they support only read-only operations. So in this example, there are two data sources, one to get default VPC, and another one is to get default security group within this VPC. And the third one mentioned here on line 10 is Terraform remote state to get information for already created resources from other Terraform execution. And it also has some default values, which is not often used by developers. So variables on another side is what you want users and Terraform to operate with. So there are literally three types of them. One is string, integer, and Boolean. This is internally the same type. And there is list and there is map. If we look into types of variables, we can see that the most powerful type is string, integer, and Boolean, because it can be used everywhere, it can be passed everywhere, and it can be interpolated in all possible places. So that's if you are unsure whether you can use something else, you can always write it safely in following string, integer, or Boolean. In upcoming versions, I will tell about this later, these red rectangles will be fixed. So Terraform state is the last concept which is important to understand for this specific talk, is that this is just JSON file which contains information about created resources. And it is used internally by Terraform, so humans often should not touch it. So if you want, you can use Terraform commands like Terraform show to get or to extract part of it. If you need to work with this JSON state file, there are commands to update parts of it and to move certain blocks around. I will talk through that later. So as an example, this specific S3 bucket called my bucket is private, and I have a lot of secret stuff there, so I don't want Terraform to accidentally delete it. This example creates security group with one security group rule, which is everything should be publicly open for ingress. And a little bit more complicated example if you want to use Terraform modules. In essence, Terraform module is a collection of resources which serve a similar goal. So it's like single function which has to be executed, and it accepts different arguments. So this code has two invocation of security group module, and different values are passed to it. The code for this module is open source, as well as code for all slides, which will be included in the presentation, is open source. So when you are starting with small infrastructure, you start almost always equally. You read documentation, you just copy examples from there, you start writing main.tf file, you declare some variables, you run Terraform init, plan, apply, everything looks good. Then you figure out that you have more than, let's say, 20 resources in one file, and you start to think that maybe there are better ways to do this, to organize code more efficiently. So that's where you come to the concept of module. Module, as I said earlier, is a grouping of resources and data sources. Data sources are used to fetch information about external dependencies, while resources are actually creating this common sense of the module. In official documentation, there is a diagram which explains whether you have to make module. And if you follow this official recommended practice, most likely you will end up in the bottom, don't write a module. I don't know why, but a lot of people think that they need to write a module for VPC, because I'm so unique, I will make my VPC module, which will be the best, and then they see this diagram, and then they figure out that, oh yeah, it's not so, so I don't need it. So I kind of agree to this diagram, but 50%. So for my understanding, there are actually two types of modules within Terraform. Some of them I create just resources, nothing else. So they're very flexible. They accept dozens of different parameters, and they have no relations to anything else. They just do what they're supposed to do, like security group. If you work with Terraform, then you may know that there are lots of different arguments for all of these resources. And resource module is just hide a lot of this for you. On another side, what I actually think has to be much more widely used is Terraform modules for infrastructure components. Like, and a good example of infrastructure module can be something what serve just your purpose. So it's collection of resource modules, like you need to create load balancer, you need to create VPC, and you need to deploy application there. And all of this can accept several parameters. So that's a good example of infrastructure module. Often company-wide standards are enforced in these infrastructure modules. And often if you have different teams working with Terraform, infrastructure module is the smallest component which can be spread across the whole company. It's totally possible to use resource modules and let developers play. But if you want to simplify it for them and still have control over what quality of the code is, then infrastructure module is often built by DevOps team and then used by individual development teams. So why on earth resource modules exist? Why cannot you use just resource natively? My answer to that is that resources cannot be versioned. And this is very important if you want to make if you want to lock your infrastructure to specific version and can have guarantee that this is my infrastructure, it has this specific version. If you use modules for that, then you can lock versions of individual modules, and that's how it is. So line 3 shows different versions when different modules are invoked. And infrastructure module on this slide shows three different invocations of resource modules to create VPC, DNS records, and specific settings for application. For the user of this Atlantis module, they don't have to know details about how VPC is implemented, how DNS is handled. They just know that this is the interface. So think about module as interface between something and something. I often think about this as an interface between DevOps team and developers who know how to write code. So few modules tip is to not write modules before you check their existence. So registry.terraform.io has more than 300 AWS modules, and I think about a couple hundreds of all other modules. And they're written by people who had been solving similar problem as you. Very common situations and very common architecture solutions were already solved for you. So things like Elastic Load Balancer or Application Load Balancer is there. So check it out, and most likely you will find solution there. There are not so many infrastructure modules for continuous integration pipelines and for other things, so you still have to most likely you will still have to write something yourself. But this is a good chance to check it out. So another often issue with Terraform 0.11 is value of count cannot be computed. So who actually wrote Terraform modules and used Terraform and saw this problem? Right, so I was so sure that at least somebody raised hand and tell this, because this is one of the hottest problems in Terraform. And if people come from a programming background, then they think that they can use cool features like loop, conditions, and so on. And they cannot understand why this is not working. In fact, it was a limitation of HCL, which is HashiCorp configuration language, which is used to describe Terraform configurations. And HCL2 is coming shortly, I guess, I hope. And it will fix a lot of these problems. So the problem is that the way how Terraform handle different types internally is that if Terraform does not know exact size of the list, then it cannot be used as a count. And count is synonym of for each loop. So this problem will be fixed with HCL2, so stay tuned. Another thing which is important is, as I said, you cannot, you should not think about Terraform as programming language. It's not made for that. It doesn't have loops. It doesn't have chances to use computed values in counts, as I showed, and also take into account where exactly your code will be executed. While working with AWS, I see this quite frequent, is that as new regions on AWS popping up, they may not have features which you expect. For example, EC2 Classic Link is simply not available in newest regions because feature itself is so ancient that they don't even bother to implement it. And also service availability is different per region. So think about this when you write your code for the module, which you then will be able to claim that it's working. Another thing is try to hide complexity for your users. So if you make a module which is creating a relational database service instance, then it has to do that. And users should not know internally that you actually making 25 calls to different resources and making them conditionally and so on. For them, it is single invocation where they pass what type of database I want to make and what key values I want to pass into it. Internally, you can use things code as here, where I check that if this is SQL Server, then create specific type of resource. If this is something else, then create it. And also, as you may see on line 19, the output is used element, concat, and coalesce list. You don't always want developers to go to interpolation documentation page and dive into specific of when to use element, when to use concat, why coalesce is necessary here, and so on. It really simplifies life and adoption of Terraform in an organization. If you hide a lot of them and say that, hey guys, this is module, this is documentation, this is example, go and use it. If they want, they can always check the source and go deeper. So this example shows that I want to create a MS SQL instance and I have possibility to specify time zone. While if I'm using MySQL, then there is no possibility to specify time zone. Size of modules is also a very challenging thing, because if you are using Terraform in organization and you have infrastructure module shared between different teams, it's very often that you have all of this in one GitHub repository, which means that when somebody specifies that they want to use version of your module, during Terraform init will actually download the whole repository and then use code which is in that specific directory. This can be solved by two different ways. One is to prefetch all these dependencies before usage, and second one, which is much better, is to actually build these small infrastructure modules and again try to treat infrastructure the same way as we do with application. So application is treated by CI and artifact is produced. So why Terraform configuration should be treated differently? So in this example, line 19 is downloading from HTTP, from Artifactory or whatever, specific module or specific version. So which means that it will be 99.9% smaller than the whole repository. This is extremely often if you have a lot of invocation of the same module, which means that every time it has to download everything. So another big topic which I'm exposed quite frequently is when I talk to people who write documentation, wrote their modules, now they have a lot of modules. So what to do with this variety of modules? Resource modules, infrastructure modules, all create something, everyone depends on something, everything is versioned. So it's like spaghetti code, but in another way. So there are two extremes. One is that we invoke all of these modules in fewer places, or literally in one place. So which is main TF for this specific application, in this specific region, in this specific environment, invoke this amount of modules. Looks good. So this is one extreme. And another extreme is that we have one module which does just one small thing, and we call it only in one time, in one place. So this is where composite pattern comes into play. As I said, many in one is invocation of a bunch of different modules from fewer places. So the bad thing in this solution is quite obvious, is pretty large scope of changes. So it's very likely that things will go bad if something is dependent on something what you don't want. And the nature of how orchestration can be implemented using Terraform is that you simply have to call Terraform sequentially in order to have things happen. Because data sources which are called at the very beginning of Terraform may not be available for the resource which is going to be created. So you need to somehow chain the invocation of this. And there is no dependency, no way to specify dependencies between modules. There are some workarounds, but they don't look so nice. So in general, this is very problematic approach. But another extreme is to reduce small blast, to reduce blast radius, which is harder to break. And it's possible to chain different executions and easy to understand what's going on. You just have to write more code or much more code. So everything in between is the most popular choice. And where everything, where is actually in between, like closer to the left or to the right, is totally up to you. I can just give some kind of guidelines or some ways how code can be structured and how compositions itself can be structured. This is so, I would say, greenfield. So I cannot say that, yeah, you have to group your code because, let's say, by logical name of environment, because it may be not so relevant for you if you share some components between staging and production. Or quite frequently is when you try to follow composition structure or try to base composition based on cloud provider services. So let's say you have networking services, which handles all type of networking things. And then you have application group of Terraform configuration and so on. So, but this is these 7 points which I highlight is what I see most frequently used. And none of them are high or low priority. You have to consider them all and think about which one makes most sense for you. I can just say that if we have less resources to manage in single run, it will be faster and secure, and in general, it's easier to think about much smaller scope. And tools like TerraGrant can allow us to orchestrate configurations and just reduce amount of code which has to be copied between these. So if you may think that orchestration is this, then this is not this. So calling Terraform from Terraform is just inception, right? It's not orchestration. I tried this code, it works, but I don't want to even use it. So orchestration is where you invoke Terraform not from within Terraform, but from something external. So typically it's shell script which goes in tree of directories and run Terraform init, Terraform plan, Terraform apply recursively or sequentially. Calling it using null resource is just hack, which can make people funny and happy. So this is not orchestration. And I also try to summarize things which I learned in the past, and when I talk to customers and different contributors, when I just check different Terraform code into this repository. So it's totally opinionated way of structuring code, defining compositions, and orchestrating different things. So that's how I think. I start writing there, but it's kind of incomplete yet. So another thing which is very important to understand when we write code is what's going to be next in Terraform 0.12 and so on. So 0.11 is currently available, and it has certain limitations which I pointed before. The biggest one is, of course, not possible to use counting lists and so on. But let's look into refactoring and what it actually means. So refactoring is just adding any change, which means add features, fix bugs, optimize different resource usage to the code, which brings code base closer to the desired state. So normally we try to make refactoring in application incremental, small, and we may accept some temporary ugliness. But talking about how this can be done, we have to think that it has two solutions. The first one is edit and pray, which is similar to finger crossed, that you just change something and run it and hope that it works. Or another one is cover and modify, which cover with test, implement some guidelines, and then modify and make sure that tests are not broken. Testing is pretty complicated as of now in Terraform, so there are no single solution which can be used. So when we start with adding new features, it's often easier, and we think that that's how it should be, because what can go wrong? If we have already created resource and we just specify a new parameter to this resource, so of course it will just change it in place or recreate this resource, and it will just update it. Yeah, it's often like this. But in many cases, you have to have some sort of backward compatibility within the module, so that if you make a module which creates VPC, that's fine. But what if you have an infrastructure module, let's say for Jenkins, and you want to make this module flexible? So then you can say, you can ask user to provide VPC ID. And if user provide VPC ID, then it means that you don't have to create it. And this code illustrates how to use data source and how to use resource to create it conditionally. Another limitation of 0.11, which will be fixed shortly, is the way how indexing works in list. So in this example, if user 2 is removed, then everything will be recreated because Terraform didn't know so well about order of these items. It means that 0, 3, and 4 will have to be moved up. It means they have to be recreated. For many situations, it's fine, but for some situations which are, for some resources which are stateful, like IAM Access Key, you don't want everyone who is following user who is going to leave company to recreate their keys, right? I mean, maybe that's good strategy, so you enforce key rotation for them, but then user 1 will never rotate his key because he will never be moved. So the solution for this is, again, we're talking about 0.11, so this will be obsolete for majority of cases once 0.12 is out. So the solution for ordered list is to provide JSONnet template. So JSONnet is what is it? Data is JSON scripting language, or how they call it. So it's JSON template will be created. No, JSON. Yeah. Anyway, JSON will be created from this file. So JSON template is used, and it defines what kind of structure you want to have. So then when you call it, you get JSON back. And Terraform natively understands HCL, which is TF file, and JSON files. So Terraform will be able to combine this and figure out what is the difference, and it will be able to help with it. Another thing with importing is if you start using Terraform not from day one in your project or in your company, then most likely you have some resources already created, and you don't want to recreate these resources. So Terraform import has been added like half year ago, maybe 1 year ago, and a lot of resources are now supported there. So if you have already created VPC, no, you don't have to tear down everything in order to start using Terraform. It's not CloudFormation, okay? So that's an important difference. And Terraforming is a project which can generate TF files from your existing resources, and it also can generate TF state file, which is very important information so that you don't have to do anything. You just point to which resource you want from now on to be able to handle with Terraform, and it will handle from there. So renaming and moving is important feature of Terraform when you are thinking about putting everything in one file, main TF, with all resources possible. And then again, it's important to not recreate resources, but just make your configuration and the whole composition easier to work with. So that's why it's important to have features like rename resources or import or move resources from one place into another module. So testing in Terraform is pretty tricky. It's, again, very greenfield area because there are not so many tools which can satisfy everyone. So basic things is like we don't want to discuss spaces versus tabs. We just want it to be done for us, and we never talk about this. Second thing is in pull request, we don't want to ask, have you run this code yourself? So that's why there are tools like Atlantis, which can execute Terraform configuration, which is in pull request, and make sure that this is what's going to be applied. And then you can say Atlantis apply, write in the comment, and it will apply this change. Or you can apply it once this pull request is approved and merged. It's a very good project. It's not so famous, I would say, as it should be, but it's there and it has to be looked. And integration testing is currently done by two things. Either it is a specific provider library like AWS spec, or it is more global, but it's written in Go, and you have to write Go code, which is called TerraTest. It was released approximately 2-3 weeks ago, and it has already reached 1,000 stars. So for me, it means that people want something like that. Maybe different solutions, maybe not even that at all, but people want to be able to test their configurations. How it's different. Edge cases to look is resources can be very different between different regions or even different AWS accounts. If you open an account, let's say before 2010, as I did, then I have some more features. That's why when I run tests in my AWS account, they always work. But when I ask someone else, hey, can you run this code, in particular Terraform AWS modules, which I maintain, sometimes it doesn't work for them, and then we have to look why. So it's sometimes very strange, like IPv6 is pretty different. And also, I encourage you to check and contribute in any way, at least with GitHub issues, to AWS provider or Terraform core. Even if you are not sure that this is intended behavior or maybe it's a bug, nobody will bite you if you just ask. That's important to understand. This is open source project. Everyone can ask. You will not be penalized if you ask. And as a summary, I want to say that plan in advance means that you have to write code which is smaller. You have to write something what hides complexity for your end users. You have to know who is your end user. If it's just you, then it's important to write so that you understand in 2 months, in 3 months. Then you just run Terraform plan and see, oh yeah, actually that's what is now in production. That's good enough. If you have chain of your dependencies, like different teams dependent on different versions of different modules, it's again important to write smaller things and hide all interpolation for them, all limitations in length of name of resources, because you probably don't know how they will use it. And they don't know that Elastic Cache, which is Redis, managed Redis by AWS, has a lot of limitations in name, in length, and what kind of characters it has to use, and that it's not allowed to end with dash at the end. Your users doesn't know this. And you maybe not know this also. So that's why there are solutions which other people wrote, and they tested it, and they know that, yes, it has to be not more than 22 characters because it's used in host name somewhere. That's why it cannot stop with dash, and so on. No underscores, and many other limitations. MySQL or Oracle should be always uppercase. Yeah, you never know. So reusing existing code and modules is important, and if there is nothing, then yes, fall back to documentation, write something, contribute it back. And with this, I want to mention a few projects which I contributed over the past 3 years. So all of this is for the community, because I want to solve the same problems fewer times. So just in random order, starting from the bottom. Terrible. What can go wrong with combining Terraform and Ansible, right? No, it's actually terrible. So terrible is a way to orchestrate and execute sequentially Terraform commands for your data structure, for your composition. So you define how your code is lined up and what kind of command you want. So it executes. I personally use it for refactoring of large amount of resources, which is about 200 of different folders, and I need to apply similar changes. Or if I have users of specific version of my module, and I know that there are 20 of different teams in one company, then I don't want to slack them and say, hey guys, new version is out, please update it. I know that I have to run some commands sequentially, update some string, run Terraform init, run Terraform plan, and nothing should be changed. So Terrapin is another one, is where I want to generate resource modules in a simpler way, which includes documentation, testing, examples, README, changelog, license, whatever else. I don't remember, it's like 9 items from single code base, because I have access to Terraform source code already. I know what kind of arguments all resources accept, what kind of attributes they outputs, and so on. And the latest addition was that just for fun, I started to work on AWS diagram as Terraform code. If you saw the slide by Mitchell, and I included it as well, where multi-tier or LAMP stack was shown, I personally think that it can be pretty cool to click export as code, and you get all code which is not as boilerplate, which you can just say, oh yeah, thank you, and delete it. No, I don't want this. I want to have a code which is actually opinionated and which is actually working. So I follow all these dependencies between all of these arrows and what point what, and if it's multi-AZ relational database service instance, then yes, it will be 2 of them, and so on. So all kind of crazy things are there. And yeah, currently it's in beta and I don't have time and money to work on it. So if you are a developer who wants to contribute, just let me know. Yeah, and second link is Terraform AWS modules is a collection of all verified Terraform AWS modules, which supported by community, and I try maintain them as much as possible. So things like VPC, Security Group, EC2 instance, RDS, and so on are all solved already for you. So if you are introducing Terraform in your company and you don't know where to start, or you think that, oh my God, I have to read documentation for RDS, and I have to read documentation for Terraform, and I have to figure out how to write this, most likely it is already solved. So there are modules for that. One of the most active right now, which guy has started, I think the same evening as Elastic Kubernetes service was launched by AWS. So he started it literally the same day, the same evening. And he already got 2-3 contributors, so they're pretty active there. It's pretty cool to see how they're contributing. So yeah, on that I want to thank you. And yeah, I hope you have questions.
Yeah. Some questions? Any questions?
Don't be shy. I mean, of course, if you're shy, there are direct messages, which is open. But
okay, one question.
What's your thoughts on Atlantis in production? What's your experience with it? And yeah, just a general thought.
Atlantis, you asked?
Yeah.
Yeah. So Atlantis, just for those who don't know, what is it? Atlantis is a tool which gives you a unified workflow with your Terraform code. So right from the pull request, you can see what's going to happen. And this is important that you don't ask human to do something what computer can do. So you don't know whether this value is even correct. Maybe it's totally wrong, and maybe it will fail miserably at the very beginning. So let machine do this for you, and you talk about something else. So Atlantis is, I don't use it in production so much at my last workplace, where I finished work yesterday. So I want to use it for open source code, even if developer of Atlantis saying that it's not a good idea to use it in production for public things. So the thing is that Atlantis has certain responsibility. Atlantis is running on machine which should be available for GitHub to be able to send webhooks to. So of course it has some webhook UIs. The problem to use with public pull requests is that somebody can commit code which does something bad. And this bad can be literally echo dollar AWS credentials just now for me here. So this means that I can submit pull request, write Atlantis plan, code will be executed on Atlantis and will be printed to me. That's bad. So the solution to that one, I think, can be to issue very short leave credentials. And so after these credentials are printed to the hacker or sent somewhere, they will be invalid automatically. So I think this can eliminate the area, at least. So, yeah. And I have also made Terraform AWS module for Atlantis to run Atlantis on AWS Fargate, which means that you should just clone this repository, provide 5-10 different parameters, and you will have it up and running. It costs, without any load, it costs 42 cents a day, which is good. I think I can afford it to pay for all open source projects which I have, which is good. Yeah.
Okay, some more questions? Still have time.
Oh yeah, the last thing is, I don't know how Mitchell forgot about it. I have stickers. That's the most important part. So I have a lot of them, so you have to definitely come and grab them.
All right. Yeah, then thanks again, Anton.
Yeah.
And